Okay. Are we live? Please. Please. Yes! Okay. Bit of an issue. The text is flipped. Now, how did I fix that last time? Okay. Okay. Looks like I'm gonna need to go floopity doop doop, and then you guys can see my Maury poster there. But that's kind of what I'm gonna need to do. That's obviously my broom and stuff. How am I gonna do this without this getting in the way? Because obviously that's the right way around. Okay. You guys are gonna need to give me a sec. Right. We should be back. There's a weird little pop-up on the side there. How do I get rid of that? There. Right. Right, so, welcome to what is going to be the beginning of a brand new revision series. So, the reason I'm doing this now, why didn't I do it at the start of the year? I got banned. I literally could not stream for a month. I don't know why, but Streamlabs just was not having it. Anytime I did a stream, it would just not work. No one could see it. So now we're back about a month later, and what this will be is I'm going to be doing a lot of biology revision. And maybe when if Ellis does come on these, which I don't know if he will, but I may also occasionally do some history revision with Ellis. Well, when Ellis is here, because obviously biology, I feel like would be more interesting overall to do. So these streams are going to be obviously made for a very specific target audience of literally like people who are taking like A-level biology, and that's kind of it, or A-level history. I'm obviously in year 12, and it is my birthday tomorrow, so what I thought is basically every Monday and I think Friday, so at the start of a week and the end of a week, we will literally go and we'll go on this, it's this physics math tutor website, and apparently they just have a bunch of quizzes, like questions for every topic, and it looks like right now there are about 16 different questions. And that is for the biochemistry unit. The biochemistry unit, but it's the biological molecules unit. That's what it's called. So, biological molecules. So, we are currently just over to the protein section. So we're not even halfway done with this topic yet, which is fair enough. So what we'll do today is I think we'll do the monomers and polymers, and then we'll jump onto cell biology. So. Now these are obviously my good old traditional revision streams, which means I'll be pulling out the whiteboard and I'll be writing stuff. I just want to verify, so everything that you guys can see should be correct. Like, it should be the right way around. Yes, okay. Everything is fine. Now, if at some point that changes and everything's flipped, let me know, because obviously I can't see from the camera's perspective, really. So anyways. So, the first question is, describe the chemical reactions involved in the conversion of polymers to monomers, monomers to polymers. I'm assuming that would be hydrolysis and condensation, which, if I check the mark scheme, yes, it is. Okay. What I usually will do for these big mark questions now is, instead of just writing all my information down and then checking, I'll check the mark scheme just to make sure I know what I'm talking about. If I start rambling about something and it's not that, then it's going to be a little bit bad. So, converting polymers. So, I guess firstly the two main ideas here: hydrolysis and condensation reactions. So those are the two main different reaction types: condensation and hydrolysis. So hydrolysis is where a water molecule is used to break apart polymers into monomers. And then meanwhile, a water molecule in a condensation reaction, a water molecule is used to, a water molecule is formed to create the bonds. So a good way is obviously, you have to think of electrolysis, where in electrolysis you're basically, you're getting, and obviously I don't do A-level chemistry, which again means I'm not going to know as much as the average person on this stuff, but electrolysis, you are obviously getting a solution and then you're basically splitting it, so the solid or whatever goes into the negative, whatever. So you're basically splitting. That's a good way to remember it. You're basically using a water molecule to split it. For this one, you're using a molecule to form. So give two named examples of polymers. So we have to describe. So I guess that's fair enough. I mean, yeah, a water molecule is used to break apart the polymers into monomers, and obviously vice versa. But I'm gonna be honest, I'm not sure how I would put that in more like formal terms. A water molecule is formed. I don't know. Give two examples of. So how many marks is this? 5. All right. Give two named examples of polymers and their associated monomers. Right. I was gonna check the mark scheme, but I think I know this. So you have polymers like. Hang on, no. Am I doing that right? Right, my thought process here is it would be somewhat like galactose, where you get. Well, no, it's like galactose plus glucose is lactose. I would assume that those would be the monomers, those would be the. I don't think it is. I think actually glucose would be the polymer, and that would mean that. I don't know. That's got me thinking though. That's got me thinking. Oh, of course. Okay. No. I was totally wrong. Right. Yeah, this, okay, why didn't I actually think of that? Amino acids. Amino acids are obviously going to be the. We literally just did this in class as well. Obviously, the teacher wasn't there, but yeah, that makes total sense. The amino acids, and then obviously, when they form together in the big ass chains, that is when you get yourself, obviously, a polymer. So yeah, right, that was a bit of a dodgy question there, but it says here, a condensation reaction joins monomers together and forms a chemical bond and releases water. Alright, I should probably drill that reaction down, drill that definition down, because that is somewhat what I said, but somewhat not what I said. If that makes sense. So, I mean, to be fair, all you'd need to mention there is water formed. Well, what does it say specifically? Oh, releases / uses. Okay. Right, I've nailed it down to 2 points there. All you need to mention is that the bonds are formed or broken and that it releases or uses water. So long as you mention those alongside your initial point. So you would say a condensation reaction, hang on, I want to check chat. No one said anything. Oh, Kieran's here, right, okay. Don't know if he's still watching. So that's the thing, I have to actually manually check chat now, which is a little tedious to do. So if it looks like I'm ignoring messages, I'm not, I literally can't see them. So yeah, condensation reaction is where monomers are joined together and that releases a molecule. And hydrolysis is where water molecule is used in order to break the bonds. So yeah, all you need is a chemical bonds broken between, and I guess you should specify monomers / polymers. So a condensation reaction is where two, I guess, monomers basically join up, and as a result, I guess I'll just put water molecule. And then this is obviously where you have that. Actually, there's an easier way of me putting that. There. 2 1 1 2. 1 2 1 1 2. Randy number. So yeah, you initially have two monomers you use for water molecule, and then a bond is formed, obviously giving you your polymer, and then the polymer here, the water molecule is then used in order to break apart the bond. So yeah, just mention the chemical bonds and how, just obviously say between the monomers. So here, it's kind of easy to visualize the chemical bond is broken between the two monomers. So yeah, that's a good actually thing, because in my revision notes, all I put for this was the hydrolysis, a water molecule, is used to. Actually, I might have put it in good terms, but guys, I'm pretty tired today. I can't remember what's true and what's not. Right, we need to also hammer down this definition. Well, this definition, the polymers and monomers and different types. I think this one's easy. Obviously, you could mention the amino acids, and that obviously forms the polypeptides. And then alpha glucose. Oh, of course, Oh, for God's sake, I'm remembering everything now. Yeah, alpha glucose is a singular, like, monomer. And then it obviously joins together to form things like glucose and starch. Right. So I probably, if I answered that in an exam, I might not have gotten a single mark for that. Because my definitions were very loose. But now if I did it, I probably would have gotten about 4. 4 out of 5. Alright, again, I don't know all of these. We haven't finished the topic yet. The diagram below... in fact, you know what? I don't want to do the overview. Let's do instead... let's just go into carbohydrates. Right here. So, the diagram below shows the structure of molecules found in organisms. Complete the label below by putting them in correct order. So we have A. I don't know if I'll be able to answer this one fully. I'm going to be totally honest. There's some stuff here that I do not recognise. But that looks to me like alpha glucose, I'm pretty sure. Alpha, I think the H is on the top. B is it a prod? A polypeptide, I think. Because it has the R group, it has the single water molecule, and then, not water molecule, the single hydrogen, and then, yeah, the carboxyl. So, yeah, and then C is a bit of a weird one. I don't recognise this. This looks like maybe nucleic acid, or maybe DNA. You have, like, something there, and then a chain of P. I don't know what P exactly. Again, have not finished this topic yet. And then D, which appears to be beta glucose. So I'll just put beta. Right. So we have to match them up. Is a monomer in an enzyme's active site? Oh, I totally know this. Okay. That one I don't know. I'm going to put a question mark. But by order of elimination, I can do this. A monomer in cellulose. That has to be beta, right? Beta glucose is, I think... okay, we'll put that one as B. Produced during photosynthesis and respiration. Wait, no, but... oh shit, hang on. Is produced during photosynthesis and respiration. Respiration produces ATP, energy. And... hang on. Forms a polymer that gives a positive result in the Bayeux test. Bayeux test is a positive result. That would obviously be Bayeux for proteins, right? So that one would be D. So that is weird then. Each letter may be used once, more than once, or not at all. Oh, okay. Produced during photosynthesis and respiration. I mean, I would have to say that sounds like energy. What are the other byproducts? Byproduct of photosynthesis is carbon dioxide taken in, oxygen released. None of these really look like oxygen. CO2 released during respiration. Water? No. I would have to say that this one may be used twice. Monomer in an enzyme's active site. I've never heard a teacher mention enzymes yet. So maybe I would know this in a couple of weeks. But I would have to say that this one is C, and then maybe also A? Tough question though, considering I have not done this. You guys need to recall, or remember, I have not done this shit yet. We have barely gone over anything to do with proteins. The teacher literally just has not been in for a couple of days. So I am missing out, right. Oh, whoa. Yep, got that one right. Absolutely, because, yeah, monomer in cellulose, that would be beta-glucose. So, yeah, that one is right. Forms a positive thing in a biuret test. Yes, that is also right. These two are the ones I got wrong. So, I think that this is DNA. I don't know. I can't really tell because we haven't done it yet. But I did actually get this one right. But this one, C, is produced during photosynthesis. Oh, of course! Because ATP, and it's a protein. You sneaky bastard. Okay. Sneaky bastard. That was a good question there. I used what little knowledge I have of the topic there, because obviously I didn't know this. So I had to fill in the blanks there. But yeah. Okay, I would have gotten 2 out of 4, but now I would have gotten all marks. You know what? And I do this so often. I thought in my head, well, hang on. ATP is a protein, right? Because I think it has something like 22 different, like, edges or something to it. Yeah. But I was like, maybe it's not. No, I doubted myself, bro. Well, that was a fun question. That tested me, though. That was a good question. Right. Oh, okay. Okay, this one looks like maybe something I would know. Who knows? Right, we got raffinose. I'll just put RA. Is a trisaccharide, so it's 3 monosaccharides. It's galactose, glucose, and fructose. Interesting. The chemical formula is displayed. Alright, obviously we know the glucose one. CHO, and then it's 6-12-6. Fructose. Why did I have to... I didn't need to go through the effort of this. This is piss easy. It's a 1-mark question. Just basic adding. How many carbon? That would just be 18. How many hydrogen? 12, 12, 12. 36. How many oxygen? 666. Whoa. I'm an idiot. No, these are... What do you call them? No, I'm getting this right. Hang on. There's a specific word that you call a molecule where it's the same, like, atoms, which are what these are. They're all 6, 12, 6, but they're arranged differently. Oh, I'm going to annoy myself because I know it. Isomers, that's it. These must all be isomers. Huh. Did I do the math wrong there? Apparently, it's only 32 hydrogen bonds. But 12, 12, 12. And then the oxygen... Oh, would you... Wow, that is kind of a scummy... Would you have needed to, like, map that out there? Because, I guess, would you say each carbon only links to 4 other bonds? So would you have needed... hang on. That is a tricky one, actually. That looked deceptively easy, but hang on a minute. It's arranged very weirdly here. So it's, yeah, C18, H... Why would it be that, though? Why would it not just be all of them added together? Double oxygen bonds. Okay, we're delving into some weird territory now. I would never have got that. I'm gonna be totally honest, I would never have gotten that. Unless there's some kind of rule or something that she's said that we have not learnt yet. Or something, because I don't even know. It says glucose, so would I have needed to draw all the different molecules, or is there just some easy way for me to know that? Because that's weird. That I would have literally just done basic addition. Yeah, basic addition. C6H12O6, C6H12O6. Yeah, they're all isomers. So how come when they're added... I'm jumping into some very weird territory on the internet. Okay, let's just jump to the next one. A biochemical test for reducing sugar. So reducing sugar is the Benedict's test where you do not shit, which one is it? Reducing, because it's a reducing agent. Describe a biochemical test to show that it contains a non-reducing sugar. So the non-reducing is the one where you do the extra step. So let's just get some numbers out here already. Let's maybe do 5. How many marks is it? 3. Oh shit. Okay. We need to narrow this down to 3 major points then. Alright. So point number 1. I'm going to be totally honest here. I forgot what the non-reducing one is. I know for a fact it's... So you get your liquid sample, you add an equal amount of Benedict's, you heat it. I remember. To an extent, you hydrolyze it and then you neutralize it. And you use an acid. But I don't remember which one that is. Let me have a quick check. Right, I'm back. You used an acid. What acid that is, I do not recall. And you probably need to know the name. So I'm just gonna put, so you obviously would add, where's my good pen got? Pocket. So you would add the liquid sample of the, or I guess raffinose solution. So you don't need to mention liquid sample. Just say, add the solution. You put the acid in. So you would add something acid to solution and heat it to hydrolyze the glycosidic bonds. Then you would neutralize by adding and use litmus to check its pH, and then you would perform Benedict's test by adding the reagent. A positive result would be if a red precipitate is formed. Right, mark scheme, let's check that. So they are saying that you would heat with acid and neutralize. For a mark? Wow. This whole thing, 1 mark. I wouldn't have even needed to mention the hydrolyzing. Literally just heat with acid and neutralize. So boil it in a water bath, or I guess just heat the solution, add an acid to break the glycosidic bonds through hydrolysis, then neutralize it. So I wouldn't have needed to mention this. Okay. Then and I guess I could have said neutralize with an alkali, maybe. Heat with Benedict's solution. So I guess where I said perform Benedict's test, just add Benedict's reagents and heat. Then a red precipitate is formed if a positive test. Yes, so that would have been probably 2 marks. I don't know, actually, I might have gotten them all. Would it have been necessary to mention heating it with Benedict's solution? Because if I put Benedict's reagents, same thing. So would I have gotten that for saying heating it, by not mentioning that you needed to heat it? Because I put heat with acid and neutralize at the start. So I'm going to be very ungenerous here. I'm going to say I got 2 marks for this one. So I would have gotten 50% there. I would argue that's very, very fair, considering, again, quite literally 50% of this subject we haven't done. So I would argue that's a perfect percentage. I very easily could have gotten that mark for the box one now, because I remembered some information. And that counting one put me off right away. I didn't understand that one. That one made barely any sense. I'm not sure how I would have been able to work that out in an exam. So I'll have to remember that one and ask for teacher. Right. How long have we been live for? Just about half an hour. Very good. Diagram. Okay, I've just looked at the answers for this one, so I've kind of spoiled it. But I do know that oxygen double bonds. So on the diagram, draw a box around one chemical group in each glucose molecule that forms a glycosidic bond. So I'm gonna write that down. the HMOH, those are the ones that are, I guess, the glycosidic bonds. Which makes sense, because then if you're adding an acid to them, you're going to break it apart. Interesting. A precipitate is produced in a positive... A student carried out a Benedict's test suggests a method other than using a colorimeter that the student could use to measure the quantity of reducing sugar. I've looked at this question before. I know the answer, but for those who don't, it's 2 marks. So what it is you basically just take the precipitate. You would take this precipitate, the red precipitate, you would filter it out. So you're just left with precipitate, and dry it, I guess, and then you would weigh it. And that would give you an exact amount of reducing sugar. So that one I would have gotten basically all the marks, but only because I've looked at the mark scheme. So that's not really fair. Let's find a one that... Let's find a one that we don't know the answer to. Shit, you know what I realised I haven't done? I haven't updated my calendar. Literally just drawing squiggles. Calendar is a mess, but hey, it is what it is. Anyways, so in an investigation, a student wants to identify the solutions in 2 beakers, A and B. She knew one beaker contained maltose, the other contained glucose. Shit. Which is which? Is maltose the one that is non-reduced, or is... I think maltose... No, maltose, it's fructose. Maybe. Sucrose, that's it. Sucrose. That's the one. Okay. So, none of these are non-reducing, they're all reducing. She did 2 separate tests. Test 1, she used, and I don't know this, used Benedict's solution to test. Test 2, she added an enzyme, maltase. So I assume that reacts with maltose, and it would probably break it apart, giving you the starch, maybe, something like that. And then you use Benedict's solution. So in test 2, explain the results for beakers A and B. So A is a positive result because the red precipitate is formed. B is also a positive result. However, it is more of a strong positive result because it turns dark red, indicating a higher concentration. What would you have said for that, though? Yep, I would have literally got that. Except higher concentration of sugar. Because more sugar / precipitate after the hydrolysis and maltase. Wait, hydrolysis was used in this? Oh, I didn't read the question! Maltose is hydrolyzed. I did say that in my prediction though, didn't I? I literally said it breaks down, so yeah, okay. So no, would I... So... A is glucose, B is maltose. Wait, you would have had to identify them? How would you have identified these? I guess B being maltose makes sense because it changes. Okay, that makes sense. And then, yeah, I would have gotten a mark because a higher concentration of sugar after the hydrolysis has occurred. More sugar, well, a higher concentration of sugar because the hydrolysis has occurred. Using a colorimeter in this investigation would improve the repeatability. Give one reason why. I mean, I checked the mark scheme just then, so it says it's quantitative and it standardizes the method. That couldn't have summed it up more perfect. Yeah, it would make it more repeatable because, yeah, it's a test that, like, yeah, that's a good one, actually. That's a good terminology. I'm going to use that. Qualitative test that standardizes the experiment. Well, I'm going to head off now. That has been a pretty decent first stream.